Let's go to number 11. Solve for x in the inequality 5x plus 2 over x minus 10 greater than or equal to 3. This is a rational inequality. Remember, you cannot times x minus 10 both sides. We do know the rule for inequalities. Mommy, daddy, nanny. Multiply, divide by negative number. Switch the symbol. We are not sure x minus 10 is a positive or negative. That's the reason you cannot do the multiplication of x minus 10 both sides. 5x plus 2 over x minus 10 greater than or equal to 3. So minus 3 both sides. 5x plus 2 over x minus 10 minus 3 greater than or equal to 0. Then we will do the operation of subtraction. Cross multiply. X minus 10 as a denominator. Then 5x plus 2 minus 3 times x minus 10 greater than or equal to 0. Distributive property 5x plus 2 minus 3x plus 30 over x minus 10 greater than or equal to 0. Combine like terms. 5x minus 3x is 2x plus 2 plus 30 is 32 over x minus 10. Then greater than or equal to 0. We will use a sign diagram to do this inequality. For the root of this rational function, 2x plus 32 equals 0. Then minus 32 both sides divided by 2. X equals negative 16. For the vertical asymptote line, x minus 10 equals 0. Then x equals 10. This is a vertical asymptote line. Then we draw a number line. This is negative 16. Here is 10. Vertical asymptote line. You will choose a number. Easy number. I choose 0 between negative 16 and 10. Then I plug 0 into this equation. F of 0 equals 2 times 0 plus 32. 0 minus 10 is less than 0. So I will put negative sign for this interval. The neighbor intervals are opposite sign. Positive here, positive here. Therefore, for the final answer is this and this. This is a root. X less than or equal to negative 16 or x greater than 10. No equal sign because this is a vertical asymptote line. Or you can write down from negative infinity to negative 16 bracket union from 10 to positive infinity. Let's go to number 12. Find the domain of the function below. We do know there are 4 functions which has a restricted domain. For square root of x, x greater than or equal to 0. For 1 over x, x not equal to 0. 1 over square root of x, x greater than 0. Log base b of x, this x greater than 0. For this function, we have a square root x squared minus 3x minus 4 greater than or equal to 0. Then we have a rational function 6x squared minus 54 not equal to 0. This way it's easy, so let's figure this out first. Add 54 both sides, then you divide it by 6. X squared not equal to 9. X not equal to plus or minus 3. For x squared minus 3x minus 4 greater than or equal to 0. Factor first, x minus 4, x plus 1 greater than or equal to 0. Then we get two roots. X1 equals 4, x2 equals negative 1. You can use a sign diagram to solve this inequality, or you can use the graph. For x squared minus 3x minus 4, graph is open up. This is the x-axis, negative 1 and 4. We are looking for greater than or equal to 0, which means above x-axis. So this is the answer. X less than or equal to negative 1 or x greater than or equal to 4. We will combine this and this together. Let's draw a number line first. Negative 1, here's 4. For positive 3, it's here. Negative 3 is here. So we can write down the domain for this function like this. Negative infinity, positive infinity. From negative infinity to negative 3. Union, negative 3 to negative 1, bracket. Union, bracket from 4 to positive infinity. Let's go to number 13. Find the domain of the function below. For the first function, we are given the domain is x less than 0. Since this is a rational function, the denominator x squared minus 1, we will set up it's not equal to 0. Then x squared not equal to 1. X not equal to plus or minus 1. Then you combine these two together, x less than 0, but x not equal to negative 1. We will put this together by using interval, negative infinity to negative 1. Union, negative 1 to 0. Let's go to second equation when x greater than or equal to 0. X plus 2 not equal to 0. X is not equal to negative 2. Then you combine these two together. It's still x greater than or equal to 0. So we will combine these two together. It will be negative infinity to negative 1. Union, negative 1 to positive infinity. This is the domain of this piecewise function. Let's go to number 14. Find the x-intercepts of the function, if any exists. If a over b equals 0, then a equals 0. So for f of x equals 0, which means the numerator 6x squared minus 7x minus 5 equals 0. Ninja x, negative 30, negative 7 over 6 over 6, negative 30. 1 times negative 30. Adding is not negative 7. 2 times negative 15. Adding is not negative 7. 3 times negative 10. Adding is negative 7. So 3, negative 10. Reduce. Negative 5 over 3. 1 over 2. Put the variable. Then bottom up. 2x plus 1 times 3x minus 5 equals 0. Then 2x plus 1 equals 0 or 3x minus 5 equals 0. x1 equals negative 1/2 or x equals positive 5 over 3. Let's go to number 15. Find the vertical and horizontal asymptotes of the function. For vertical asymptote line, we will set up a denominator equals 0. Ninja x, 4 times negative 7, negative 28, negative 12 over 4 over 4. Negative 28, 1 times negative 28. Adding is not negative 12. 2 times negative 14. Adding is negative 12. So 2 and a negative 14. Reduce negative 7 over 2, 1 over 2. Then we put x. Bottom up. 2x plus 1 times 2x minus 7 equals 0. X equals negative 1/2. X equals 7 over 2, vertical asymptote line. For horizontal asymptote line, we will do the limit as x approaches infinity of the function 6x squared minus 7x minus 5 over 4x squared minus 12x minus 7. If you learn L'Hopital's rule, you can use that. Or we will use this limit as x approaches infinity of 1 over x to the nth power equals 0. We divide it by x squared top and bottom. We will get limit as x approaches infinity of 6 minus 7 over x minus 5 over x squared. 4 minus 12 over x minus 7 over x squared. When x approaches infinity, this is 0, 0, 0, 0. So the final answer is 6 over 4. That is 3 over 2, which means y equals 3 over 2 is the horizontal asymptote line.